Hey y'all, Data Guy here. And today I have a video for you that was actually based off of a pipeline and use case developed by my colleague Manmeet. So hats off to her, link to her kind of whole breakdown in the description. But what I'm going to do here is really show you, walk you through every step of the way, building an end-to-end data engineering pipeline, as you can kind of see here, that implements change data capture. So what we're doing here is basically loading data from one database that describes our front-end users, applications, OLTP database, bringing it into a landing storage area, and then ingesting it, auditing it, capturing any data changes that happen before uploading it back into our data analytics database, and which is going to be based on OLAP. So the two tools we're going to be having, our source database will be a Postgres SQL database, and our target database will be a Snowflake database. We'll aim to hit a inter-day batch sync frequency and basically take three different source tables: customer, customer address, customer payment, collate them, and then store them in one target table called customer. So what we'll do is a full sync initially, and then daily incremental syncs based on the timestamp column in the source table of updated at. Then our target data will be an SCD Type 2 database as well. So basically take all the information around our customers, co-locate it, bring it into one table, and then capture any of the change in the data that happened within that process. So this is going to involve some custom operators. This is going to involve just a lot of the basics that you need to understand to build a actual production data pipeline. And so the prerequisites for what you're going to need here are, number one, a Postgres database. And so I'm actually just going to be using the Postgres database that's spun up alongside Airflow, which you can just access. I'll show you this at localhost 5432. And then you'll also need a Snowflake database. So the database that we're going to be storing everything in will be within Snowflake. And for that, you're just going to want to get a Snowflake free trial, which you can get at snowflake.com. Just sign up with an email and then use that database to store it. You could also choose to sub out Snowflake with the database that you actually have access to, but just I'm going to be following it by the letter and using a Snowflake database. So without further ado, I'm going to switch it over into our local Airflow environment, show you how we're going to get set up, and then we can start building our change data capture pipeline. So to run my local Airflow environment, I'm going to be using the Astro CLI, which you can access by just running brew install Astro, and then Astro, if you want to create a new completely blank folder, Astro dev init here, and this will, I've already done it, so I already have a folder here that's set up called SDC pipelines, and then you can run Astro dev start after that. And what this will do is run Airflow environment on Docker desktop. If you don't have Docker desktop, you can also substitute for using Podman instead, similar Docker-based technology, just with a different provider. Then, once you're set up here, before we actually start running our DAGs, you're going to need to add two packages to your requirements file. The Airflow provider's Postgres, and then the Airflow provider for Snowflake. These are just providers that will allow us to interact with both Snowflake and Postgres and install any necessary packages needed for actually interacting with those database services. Additionally, you're going to want to have a SQL folder you're going to create within your include directory. So this won't come out of the box. You'll need to create a new folder. And then within this SQL folder, we're going to be storing a few different SQL scripts as we write our DAGs. So we don't have to have them hard-coded within our Airflow pipeline, which is just basic best practices when you're using repeatable SQL scripts within a pipeline. And then once you have that all set up, we can go open our DAGs folder and create a Python file for our first DAG. So here I'm just going to call this new pipeline cdc pipeline.py, and then what we can do is actually get started writing. So now the first thing that we're going to want to do, as we do with pretty much all of our Airflow DAGs, is actually import some packages. So the first things we're going to import are OS, logging, and datetime. And these are just kind of base system level packages that you just need for doing some typical Airflow operations like pulling environment variables from your operating system, pushing messages out and pulling messages from the logs, and also just having a standard datetime component so you don't have to kind of fuss around with the default datetime and you're worrying about the variables there. Then for our Airflow specific packages, what we will do is bring in our classic DAG model, our variables, so we can use Airflow variables, our task decorator, so we can write Python tasks with just a decorator instead of needing to use the Python operator, even though it effectively is the Python operator on the hood. And then we're also going to use the Postgres hook to interact with our Postgres source database a Snowflake hook to interact with our Snowflake target database, and then also our SQL execute query operator for executing SQL queries in either database. Then we also have our S3 hook, which is just kind of we're going to use as an intermediary staging location and for our data as we move it from our source table to our destination table. So now that we've got all of our packages imported, we can start writing our actual DAG. But fake out, just 1 second, we're also going to need to just define our source tables. So these are the tables within the Postgres database that you're going to want to be pulling from. So customer, customer address, and customer payment. Then we can actually use the DAG or create a DAG. So here, what we're going to do is we have with DAG ETL DB to DB, start date, date time, catch up interval, daily. And then what this template search path is doing is basically telling this DAG to, when I reference just a base file, to pull it from this ETL DB to DB folder. And this is the folder where we're going to be storing all of our SQL commands that we're going to be using within this DAG. And I'll pull up a SQL command as needed as we're building them into the actual DAG, which we'll start now. So the first task we're going to find is getting our DAG configurations. So here we have task multiple outputs equals true. And what we are going to do here is build a task which is going to retrieve the configuration of a DAG from our Airflow variables. And this is also going to basically be what determines the type of data load we're going to use, whether it's the full or if it's just an incremental data load based on the delta of time between when we last conducted a data load. And then what this will do is conduct then a conditional SQL clause based on this. So if we start building the DAG here, first what we'll do is just load the DAG configuration from our customer variable. And so this is just doing as I just described. This is going to pull in our customer variable, which is as a dictionary. And if there's no customer variable defined, this will just default as a load or as a empty dictionary. And then load type is if there is a value, then it'll say, well, this is a full or partial load, otherwise defaulting to none, and then print the current DAG configuration and run type. Then, once we're done with that, what we'll do is create a conditional statement. So after we print the DAG, the run of the run type, and if the run type is equal to scheduled and load type is equal to full, then the full run can't be scheduled because it currently has a full load within the pipeline. Then, now if build some additional logic here. So after this if statement and separate from it, if the load type is full, where a conditional is equal to none, so this value actually was a null value, then we're going to want to do a full load. If the load type is delta, then we're going to want to update past the last maximum date. And if it's another type of load, then we're going to get an invalid load type because the DAG doesn't support that type of load. Then we're just going to return what the condition is and what the load type is. So once we're done with that, we can just declare this task as we would any other task. And then this will just instantiate the task as a task using the task API. After that, we're going to use the new task API branching operator to check full load. So if the load type is full, return full transform and full load. If the load type is delta, then just do the transform and CDC load. So this is going to be change data capture. So if we don't need a full load, we just want to capture what data is being changed and then make those changes as well. Then to link that to our previous task, what we'll do here is just set the output of that previous task DAG config, pull in the specific load type, and then pass that in as the checking variable for this branch operator. After we're done with that, we'll build our first SQL query or first SQL execute query operator. So here, this is when we're going to start building our SQL statements out. So here for our full transform SQL execute query operator, we'll connect to our Snowflake database, and then it will run this SQL statement. So here we have our full customer transform, where we're going to overwrite into our temporary customer table, the ETL key, ID, name, all the different information around the customer, and then select using that key, so just the key of which ETL job it's actually doing, And then what it's also doing is just joining the customer table with the customer address and the customer payment. So we have just one singular customer database that we can then use, as is the goal in this pipeline. So that's our first SQL transform operator if we want to do a full transformation. Then we also have a full load. So once our data has been amalgamated via that transform function into one common table, we then have this full load SQL query operator. And here, what we're doing is executing this full load SQL, where we're creating or replacing a table, data model, customer, and then selecting from that previous table, or that table we just created, which is the amalgamation of those three base tables, overwriting into them and selecting from our temporary table and inserting it into our new customer data model. Next, what we have is, let's say we don't want to do a full load, we want to just do a small transformation. Here, what we'll do is just do a transform job here, where we're going to transform equals SQL execute query operator. And the difference here is that we have the customer transform SQL, where what it will do is basically copy what we did in the full transform, which is just figuring out, just adding those three tables together, joining them on customer ID. But then also when we're inserting into the table, so instead of just doing a bulk insert, what we're actually doing here is saying, hey, we want to insert any change records that are already in the data warehouse. So if there are any dates or records that are tied to a particular customer ID, we want to overwrite them with the most recent data. And that's what's happening here. Is this will be to basically taking account of any changed instances and then making sure that the most current and relevant information is being loaded when we do our load in the next step. So our next step is CDC load. So here we are loading just an incremental amount of data and then capturing that change. And so here what we're doing is we're going to update and insert data into the customer table within the existing data model schema. So each part is going to first identify the existing rows in the data table that have been updated, indicate the rows are no longer based on the current version. So here we have kind of this logic here where we're checking for current timestamp. And then what we're going to do is mark any non-current records with an N. So that's here, non-current version. And then what we'll also do is say, hey, any ETLs where the thing is current, then it's only going to apply to roles. So joining the temporary table into our actual target table, or yeah. We only want to make the changes where the ETL current indication is Y, which means that this record is the current most active version. So this way we'll eliminate any previous outdated records, and they'll be replaced with these newly created records with a composite hash of MD5, which is just basically taking all the changes that occurred, and this is our record of the change between the source and the target data table. And so that's what this HWM stands for, is high watermark. Then our next step here is inserting updated records as new rows into the data model customer table and preserving the history of changes. So here we're selecting just some data from that temporary table that contains the new information we want to upload, set ETL to the current, or timestamp to the current timestamp, and then we're joining the source table with a subquery that is selecting the latest version of each record from the data model.customer, where ETL current indicator is N, making sure that we're just updating to previously inactive records. And then we're also filtering for records where the MD5 hash key field differs between the source and the target, which indicates a change and update to that particular record. And then this qualify clause in the row number window ensure that only the most recent record for each ID is considered for updates. So that way we're not just updating existing old records and then also updating new records as well, and kind of creating those double inserts. Then finally, so once we have kind of our new records to be updated, we have identified which records need to be replaced. We're then going to add new records into the data model customer table that do not exist in the target table. So here we're just selecting data. This is very similar to before, just selecting data from the source table, the temporary table of those joined three customer data sets, and then performing a left join between the source and target tables and filtering for records where the ID does not exist in the target table, and this is just kind of a fail-safe in case we miss anything within this conditional logic, to only insert new records and not just duplicate records. And this script really is kind of the crux of managing the lifecycle of customer records within this data warehouse, using slowly changing dimension type 2 methodology, which allows for the tracking of historical changes to customer data, updates those existing records to mark them as historical when changes are detected, and then inserting updated records as new current versions and adding new records when they don't exist in the target table. So you'll notice we're still preserving these older records. We're just saying, hey, these are no longer current. And now whenever you're querying, you want to only query for these new updated records. And so then if we go back to our CDC pipeline for source table within source tables, so this is going to create a task group that is going to allow us to iterate through various source tables within our Postgres database. Here, what we can do is define a task that's going to extract all of these different records. So here we have our Postgres hook, extract schema equals Postgres, Postgres connection ID equals Postgres. And then what we're doing here is extracting through each data using our SQL configuration. So here we have include. So this is just basically going to read our source table, which we've defined up here for each of these source tables in source table. So I iterate through there, get the information from that particular source table within Postgres, read it into as a CSV. And then what we're going to do is check whether we want to do a full or an incremental load, and then only so for a full load, just copying the entire table. And then within this partial load, which is just going to be incremental change data load, here we want to make sure that we're only getting data that has been generated after our max updated data. So that's kind of the conditional logic there. And then we're executing that SQL statement to basically take, hey, all the most recent records from our customer tables, copy that into our kind of like temporary file location, which is what this std out is. So copying it and then dropping it into an S3 bucket as kind of intermediary location between Postgres and Snowflake. Because you can't, I'm not going to say you can't, but it's pretty difficult to just go directly from Postgres into Snowflake. Having this kind of intermediary location of an S3 bucket makes the whole process much easier. Then the next thing we're going to do is for each task within this, for each source table here, we're actually going to have another task within this task group loop, which is going to just run this stage task, or the SQL script, which is just going to copy from our Postgres stage, so that's Snowflake, or the S3 bucket in between, into a Snowflake staging area. Which is where we're eventually going to do the transformations and load it into a permanent Snowflake table. So you can see here we have Postgres external stage, file type, so that it knows to read this as a CSV, and then using this as an intermediary location, as I said before, between Postgres and Snowflake. Then, once we're done with that, we have another task, which is going to just collect metadata around the jobs that we just ran. So here, what we're going to do is this is going to run after our data loading jobs have, where we're going to use a Snowflake hook to read into Snowflake, read in the format of our source table, read in a just quick understanding of what the data is, see this result, fetch all the information around this source table. And then, again, what this is doing is finding that maximum updated timestamp, which you can see here. So getting the last record, so this is just a reference to the information table. So getting the final, most recently updated record, and then setting that as our variable for our source table max updated. So this is what it's going to allow future DAG runs to know, hey, this is the data set that you should be getting, the data that's been produced since this max updated variable, which encapsulates the last update to our actual final target table. Then we're going to tie it all together with some nice little bit mapping here, where we're going to extract source table to stage to collect metadata, source table, check full load, full transform, full load, and then check full load, transform, CDC. So cut over to the Airflow UI now and just show you what that looks like within the Airflow UI. So now here, what you can see is our DAG actually running. But let me want to focus on here because I'm also going to show you how to set up the connections and everything else you'll need to actually run this effectively. But I wanted to just show you kind of what the DAG we just produced did. So you can see here, we're first getting the DAG configuration. Then we're running these extract jobs in parallel. So this is a great advantage of using Airflow for a type of job like this is you can extract all those 3 source tables in parallel, get it done as quickly as possible, load them all into that S3 bucket, then loading them into our Snowflake staging table, getting the max date to figure out when the last time they were actually updated is, and then checking for a full or partial load, and then executing either the partial load via transform and CDC load, and or if it's a full load for the first time, you'll use a full transform and full load here. And then what you're also going to want to do here is set up your Snowflake and Postgres tables. So for Postgres, what you want to do if you're like me and you're lazy is just set it as Postgres, localhost, and then just put in Postgres for the host, not localhost. Sorry, I had to double check myself. Then Postgres for the login, Postgres for the password, and put 5432 for the port. And this will just use a local Airflow Postgres database as a storage table. And you're going to have to upload those data tables into the CSVs into that source table. And don't worry, link in the description will be for those actual data tables. And then to also set up the initial load, you're also going to need to create a Snowflake key or Snowflake credential, and then create staging tables, creating a temp transform table, so our customer, and then also our final reporting table with data model. And then you can execute these in Snowflake if you want, or if you choose to use something other than Snowflake, you can choose to do that there. And then our OLTP, this is the initial setup to kind of mimic the customer information. But here you have your creating table, then public. So this is just basically a script that will mimic customer data and just insert it into these create tables for public customer payment, customer address. So if you don't want to upload any data, you can just run this script and it'll just create dummy data for each of those 3 tables that is timestamped over 3 days. So you can show how this is incremental and a full load will actually perform within your database. So really useful tool, and really, really hats off to Manmeet for putting this all together. She is absolutely goated. Then final step here is just adding a Snowflake table or Snowflake connection as well. So here, Snowflake con ID, and then choose Snowflake. And then here, what you can do is just add your schema. So data model, whatever your login and password is, and then your account name. So this is going to be something like so your account and org ID, and then your data Snowflake warehouse, which is customers. You don't even need to specify warehouse. I'm not going to do that. And then US East and admin East and account admin, so you can be able to create tables programmatically. And then here, this is all you need. So now you have your Postgres Snowflake table, and you can go and run a full ETL pipeline with change data capture on your own. So I hope you enjoyed this video. Really, thank you, Manmeet, for putting this together. She is the true hero here, and I hope you enjoyed some of her very, very fine work and can hopefully adapt it to your own use case. So have a good one, y'all. Data Guy out.